Should be recording. Take it away, Hayden.
Alrighty. Thank you for that, Dan. I might just quickly share screen with this tutorial here. So, just a quick little intro of what we're doing today. We are learning week 8 revision today, and we're doing it a little bit differently. We're trying to do it in Minecraft. And for those of you who are in Minecraft, just before I keep going, how's the sound? Is the sound a little bit too loud for everybody, or is it still okay? Is it a bit if it's a bit loud, turn it down, please. You know what? That's a great call. All right. Gotcha. See, these are the things I should have been troubleshooting while we were waiting. There we go. Okay. Okay, how's that? Doing better, team?
I think that's better. Yeah, while you're talking,
Excellent.
it's probably good to have it on low.
Low. Excellent. All right. I might even, you know what, just even a little bit lower. Oh, the woes of trying new things, Dan, the woes of trying new
Yeah.
things. Anyway, back
Okay,
to it.
that's good.
So we're doing this week a little bit differently. We're trying to do it in Minecraft. We'll see how we go, see if we like it. But for those of you who have joined me in the world, at the back half, after the quick revision, there is going to be a building competition where you're going to get one topic that's genetics related, and you're going to get one topic that's sort of pop culture, maybe just something cool, and then we're going to give you about 15 minutes to build, and we'll award a winner for the best genetics sculpture or concept. So we'll base it off 3 different criteria. The first is going to be the accuracy of how well they represent the topic, then how well they mix in the topics together, and then thirdly we'll have audience choice. So those who are in the audience now, you'll get to have a bit of a vote as well. Also, but don't worry, there is going to be a quick revision lesson for our competitors. So we're going to do about 15 to 20-minute quick revision beforehand before they get into it. But I still do have some space. So I think I have about 3 slots left. So if you are a Java Edition user of Minecraft and you'd like to join us in the world here, I think we've got, about 3 or 4 spots. So just send me those usernames in the chat if you have them, and I can add you into the world here so you can join us for that. But if you'd prefer not to, that's all good. Feel free to sit back and relax and just enjoy what we got going on. All right, so team, if you'd like to follow me through to our first exhibit here. I'd like to thank my lovely girlfriend Jessica as well, who made everything pretty for us. So I did all the sculptures, but everything that looks pretty, you can put down to her. So you can thank her for that. But just to get it started off, hopefully this is very easy revision for everybody, just to give you a basic understanding of how I've represented things today. The pink glazed terracotta, not very good for generic building, but very good if you're trying to give direction of your DNA strand. So all the wood that's not shaved, that's DNA, and the arrow indicates the direction that it goes 5' to 3'. And we also have the adenine binding to thymine, and then we also have guanine binding to cytosine. So hopefully that's just a little bit of easy revision for everybody and a bit of understanding of what the DNA structure might look like. But going on to the next one here, the representation. Once you have your DNA, you then go ahead and you get yourself the next stage, meaning the generation of mRNA as well. So you have your, hopefully this is simple revision for everybody, but you have your 2 strands separating out, and then you have your your RNA polymerase represented by the golden blackstone here, going down the line in the direction and then creating the replicated mRNA strand. And for the rest of the sculptures, the mRNA strand is represented by stripped logs. So if you see stripped logs, you're going to have an mRNA strand. Also, for those of you hopefully have noticed that the diamonds have been swapped out for iron blocks, and that's meant to represent your swap out from thymine to uracil. All right, so moving on to the next one here. So once you have your RNA, right, it's got your created RNA, it needs to be matured. And hopefully that you remember back to a previous previous practical where we had the individual exons being cut out, leaving behind the introns. So in this one here, the red sections on either end representing our exons, and the blue section in the center here representing our introns getting cut out until you have your mature RNA strand here. And then your mature RNA strand gets sent out into the world to a Golgi apparatus or to the endoplasmic reticulum, and then comes across a ribosome. So this big orange blob behind here represents our ribosome, having 3 individual sections. The first section here is where one of the most important ones, as it takes the tRNA and helps it find its codon. At this point, you have your nucleotides grouping together in groups of 3 to allow you to have your anticodons come together. So anticodons being just a group of 3 nucleotides that bind onto the codon itself. And then you have a ribosomal structure of the RNA-based structure after that. And then on top, control's not working, you have your amino acid attached to the top here. So this copper bulb is just representing any amino acid. And you have your tRNA coming along, being fitted into the first chamber, matching up with the codon to the anticodon. Then, as the ribosome moves down, you're going to have this tRNA move into the second structure here. And the second chamber is where one of the second most important parts happen. 2 important things happen here. Firstly, you have the dissociation of the codon. So it starts to weaken. It doesn't fully unbind just yet. And you have your top amino acid bind on to the next one that comes in. So as the ribosome moves down and the tRNA in the first chamber moves to the second chamber, it has another tRNA follow up right behind it with a strong bound anticodon. So the first tRNA then gets bound onto here to create a chain, so it sticks together. Then the ribosome moves down even further, and then you have the third chamber, which is sort of like where everything gets kicked out. Your tRNA without the amino acid gets broken off and then sort of gets dislodged, and then out another exit port, you have that amino acid chain going together. And that's how you end up with your RNA becoming your amino acid sequence. And so that's just a quick revision of how you go from getting a gene through the central dogma to get yourself an amino acid sequence. Genes can come into many different forms and types. So in essence, there are some genes that are affected by things like time and location, and there are ones that aren't. So there are some. Are we going to do it? Who's going to do it? Oh no, it didn't. Oh, there he is. Okay. Oh, Milo. Nah. Oh, where's Xenia? Where does Xenia go? Oh no, you're here. You didn't go down. Who went down? Who fell down? Oh my God, Ella. Yeah. All right, anyway, back to it. This is all to represent a housekeeper gene. Okay, I'm coming. I'm getting you. I'm getting you. Don't worry, I'm getting you. Get out. Okay. Xenia. This is falling apart. All right, so back to it. Housekeeper genes. So housekeeper genes are the types of genes that are unique in a way that they aren't actually impacted as much by time and space. So an example of one of these genes would be like GAPGH. And those, in general, housekeeper genes are sort of generally expressed at the same level over any sort of period of time. And that makes them very useful to compare other genes to. Because if you have like GAPDH, which stays at the same concentration and same expression level over all the time, like most of the time, unless your cell is super sick or whatever, then you're going to have your genes that are regulated based off time, such as like testosterone and estrogen during puberty, and you'd be able to compare them to GAP GDH and see, oh man, it's way higher than it was. So there are other genes that are affected by things such as timing and space. And you might also have other genes like heat shock genes. Like if you put your hand on a hot stove, you're going to have your genes be reacting to that for a short amount of time as well. And that might also bring over to the space as well. Particular tissues have particular gene expression. So for instance, what's another one? Like hemoglobin is only going to be expressed in the bone marrow, right? Like you're not going to have, and also in the liver, you're not going to have that be expressed in the brain because you don't want your brain to be generating blood. So you've got genes that can are affected by two things: the time, like age, or in response to something, or like wound healing over a specific time frame, or in a particular area, such as to fulfill a particular function. And if it doesn't fall under that, then we generally refer to them as housekeeper genes, and that's why I set up a house here to regulate that. So that knowing that we have different ideas of when particular genes are used, there are a few different regulation mechanisms, and I sort of just listed them out here for my own sake so that I don't miss any of them. To start off with, when it comes to transcription itself, transcription, right? The reason why it's called transcription is because you're going from DNA to RNA. And it's when you transcribe something, it's very similar. You know, like how you have somebody who transcribes, a monk back in the medieval times would transcribe words from one book to another. So they're transcribing the same language, right? So it's considered transcribing. And there's three things we're going to talk about when it comes to transcribing. We've got the core promoter. We also have alternative splicing, and then we've got proximal and distal promoters. And then when you get to the next stage, when you're going from mRNA to your amino acid, then that's called translation because you're going from RNA to amino acids, and that's like doing a whole language change, right? That's kind of like trying to read the code in the enchanting table. That's like a different language. Like English to that is a translation. So it's kind of like going where RNA is English and the amino acid is the enchanting language in the enchanting table in such a way. And there's two concepts in translation here that we're going to go over, but there's so many. Ribosome binding, so that's that orange blob we're talking about before, how we actually get that to bind where we want it to. And the second being mRNA stability. Stability meaning what stops it from degrading too quickly. So we'll talk about translation first, and we'll talk about this guy right here. So this is to help visualize the idea of proximal and distal components. So if this is your start of translation right here, so back through this way, if you can imagine the extension of the genes going this way, this is where your transcription starts. So your gene and your RNA polymerase binds on here and continues down that way. So upstream of it, directly upstream of it, say within the first 100 base pairs or so, we have the core promoter region where we have your general transcriptions binding into this region here in what's called the TATA box, the TATA box.
Excuse me.
And you have, this is like the biggest impact here. Hello, Rith. Good to see you. Good to see you made it.
This is the 5 UTI region. Wait, you're
Yes.
talking about. Okay.
Exactly, exactly. Oh, feel free to chime in, anybody in the chat or anything like that. If you have a question, no harm, no foul. I don't mind being interrupted. It's all good. This is also where you can, generally speaking, the biggest impact has from transcription factors. So that's I have this as a 3 high versus a 2 high and a 1 high, because this is sort of where, generally speaking, you can expect the most bang for your buck when it comes to transcription factors. The next region here, this is called the proximal region. And it has a little bit less generally than the core promoter region, but it's still strong. So this goes up to 250 base pairs, 250 base pairs. And it has things such as enhancers and silencers. Red and green to help represent enhancers and silencers. So that's the 250 range. You can expect that to happen. And then all the way down here, we're talking thousands upstream, thousands of base pairs. That's why it's all the way far over here. But it's also got generally the lowest impact. Oh, Thomas, yes. We've got Ava. Ava, we'll see. Hold on, we'll take a quick pause here. Actually, I'll finish up this display first, and then I'll look to invite other people in if they'd like to join. So, distal area up here is weaker than the others, generally speaking, and it's where you have a lot of activators and repressors. So all of these different components, right? You've got your distal, you've got your proximal, and your core promoter. How do they actually work together, like in 3D space? Follow me into here, where I've got a diagram on the ground. And while we're looking at this, I might just take a quick break to literally to try and add people. All right. So Ava, is that yours? We'll see if we can't add you in, Ava, to this. Invite player, see if that works. Beautiful. And is there anybody else who's added there? If you've got your Java edition username here, feel free to send it in the chat, and then I can add you in. All right, but we'll go back into it. So now that we've digested that for a little bit, so follow me, if you would, at this end of the DNA strand up here. So as you're coming down the DNA strand, you then come across, say, for example, a distal element here, an enhancer. We'll get into what those mean in a moment. All right, Haley, I see you there. I'll add you just after I finish this exhibit. I'll add you in. All right, and then we continue on a little. So you might have certain transcription factors bind here. Follow me further down here, and then you start to get to the proximal and the tartar box in here. So you then have about 20 or so different transcription factors on you can have about 20. It can get really complex, and then they all bind in together to have this cyclical structure. And the whole point of this is to get the RNA polymerase to stay in one spot. So you've got your start of transcription happening here, and that would continue down the strand, and then you'd have your mRNA strand coming out the side. But then once it gets to the end, instead of just floating off into the ether, because it's bound to the upper region here, it's going to get pulled back, and then it's going to have a lot easier of a time finding the start of transcription again. So this whole thing here, the whole point of it is to have various transcription factors hold the RNA polymerase closer to the region where it starts to the start of transcription. And it does this through a whole bunch of enhancers, transcription factors, and this complex system can have around 20 or so different transcription factors in it. And just so to clear up the activators and repressors versus enhancers and silencers, this is something you might have to just rote learn. Unfortunately, activators are transcription factors that bind to enhancers, which are the location in the gene, and repressors are transcription factors that bind to the silencers in the gene. All right. So this is, we'll just ignore that. Anyway, so activators are transcription factors which bind to enhancers, and repressors are transcription factors that bind to silencers. And you can probably guess by the name, the activators are the ones that help activators, enhancers, and help increase, and then repressors and silencers help decrease gene regulation. All right, so moving on. Yes, and now it was, just give me one moment to get Haley in here before the next exhibit. All right. Hopefully that works. Beautiful. All right, excellent. So now alternative splicing. This is a little bit interesting because what you would have been told is that all exons get into the mRNA strand. And if I told you that before, I'm sorry, I lied a little bit, just a smidge. Oh, sorry, Thomas, did you send yours in, Thomas? Tomkin, there you are. Sorry, Thomas, I missed you there. Thank you for reminding me. One moment, guys. I will add in Thomas, and I think. All right, so how many people we got in at the moment? 1, 2, 3, 4, 5, 6, 7, 8, 9. I think we're full at this point. I'm sorry, team. We have room for 9 people plus myself. So I think that's everybody. But when it comes to alternative splicing, not all exons actually make it into the mRNA. So the same concept, all introns get cut out. They don't make it. And then some exons get into the mature mRNA strand. So let's say in this original mRNA strand sequence in the center here, think about hemoglobin, for example. So for instance, hemoglobin actually changes from when you're a fetus to when you're a fully grown adult. You have a fetal version of your hemoglobin, which is slightly different to your adult version. So when you're young, you have a singular mRNA product for your hemoglobin, and then to get the fetal version, you might cut out the last exon to get only the first 3 exons, and you end up with your fetal version of your hemoglobin. But then when you become an adult, or you start to mature, I should say, instead of losing the 4th and final exon, you start to cut out the red exon in the center and you get the more mature version. So I think that, don't quote me on that being like exactly how the the hemoglobin works for fetal versus mature, but the same concept applies where you can have different versions of a protein, or sometimes even completely different proteins. I'm sure there's an example of completely different proteins, but different versions of the protein based on which exons get included in your mRNA, and that's what we call alternative splicing. And so now that's how you regulate translation. Tomkin, welcome. You made it. Good to see you. All right. So we've gone over the TA box, proximal, distal elements, how they form into complex boxes so that your RNA stays in place, how your alternative splicing can give you different mature RNA strands. Now, once you have a mature RNA strand, we go over to what's called translational regulation. And there's 2 big mechanisms we're going to talk about here. The first one being your ribosomal binding, and the second one here being endonuclease control, or the nuclease mRNA stability. I accidentally got rid of my fishing rod. Hold on. There we go. So one example of how you might increase the generation of amino acid sequences from your RNA sample comes from increasing the rate at which your ribosome actually binds on. And one way they can do that is forming a hairpin loop in the 5' untranslated region, allowing it to be easier for your ribosome to bind in here, as one example here. So you have your hairpin loop here, which forms a particular structure which might allow like a transcription factor or a growth factor to bind on to the hairpin loop itself, then making it easier for your ribosome to bind on and start creating that amino acid sequence that we talked about over there just behind us. So This isn't always the case. Just because you get a hairpin loop at the front of your mRNA strand doesn't mean you're going to have an upregulation of your amino acid creation. It might be the opposite, actually. So it might form a hairpin loop that gets a particular transcription factor that actually makes it harder for your ribosome to bind on. So this is I'm just in this example, I'm using it as a positive, but it can also be a negative. So it doesn't have to be positive, like an activator, so to speak. On the other end, so to speak, we also have some hairpin loops, a similar idea where we have hairpin loop structures that get transcription factors, and these bound transcription factors can impact whether you have your endonucleases degrading your mRNA. So a very typical way for your mRNA strand to get chewed up and degraded over time is by enzymes going to the back end and then going forwards. So that can be through like the poly A tail, as you might have remembered a structure being. So in this example here, we've got a couple of hairpin loops with different transcription factors binding in, making it harder for the endonuclease enzyme to go in and digest and break down the mRNA strand from the tail version. But once again, this also doesn't have to be this way as well. It can also be a activator for the endonuclease, making it easier. So just in this example, I'm using it as an inhibitor, but it can also be the opposite where it's an activator. This is just to give you the idea of how endonucleases can be regulated by this sort of structure at the end. And that brings us to the end of the revision session, and we're pretty much halfway through. Excellent. So everybody, if you'd follow me over here, we're going to get into the building competition. So in here, wait, is everybody here? 1, 2, 3, 4, 5, 6. Who are we missing? Come on, Ella. Come on. That's all right, Tomkin. That's okay. 1, 2, 3, 4, 5, 6, 7. Actually, I think we do have space for more people. You're on a trackpad. Oh no, that's okay. Just call me EJ. All right, EJ, I got you. I got you, EJ. All right, I think we might actually have space for more people, I believe. Do you have room for one more, sir? Let's see. We might add a couple more people. So we've got 1, 2, 3, 4, 5, 6, 7. So we should actually have room for 2 more people. We'll see how this goes with Melon Pan and Kobe. Let's see if we can get Kobe in here. Oh, I'm sorry, Kobe. We're in Java edition, so I think you might have Bedrock there. Was there anyone? If not, that's okay. We can just run it with who we've got. But, oh, yeah, rip Kobe. All right, here we go. Bro, you're on Java. Hold on, did I enter it in correctly then? So it's Donovan. Let me try it one more time. Okay, sorry, Kobe. I don't think that one's not working for some reason. And if anybody else, okay. Anyway, animation's in. Is anybody, we're missing anybody? I guess we'll give it a sec for the other person to join in. All right, so you're gonna everybody's gonna click on the dispenser. Welcome. I'm glad to see you made it. Everybody gets to click on the dispenser. One dispenser eats once. Display, if you don't mind, when you find a plot of land to build in, feel free to display, please display your pieces of paper here on the item frames available to you. You're going to have 15 minutes to build, and your building can be within these perimeters, but it cannot go over into the wood area. So anything on the grass, including this little glowstone bit, is available to you, but it must be within the bounds. So, Who wants to go first? You don't have to keep the polar bears. You can kill them if you want. Both builds, you're incorporating them together. So you're trying to incorporate both the concepts you get incorporated into one build. So you get to have, there's 30 points on the line here, right? So there's 10 points for accuracy. There's 10 points for how creative you are at incorporating your different topics together. And then there's 10 points based on audience votes. So everybody take up positions and please display your paper for all to see. And I'll let you know once the timer starts. You're welcome to get set up. You're welcome to put items in your hotbars. You just don't place any blocks just yet. You're welcome to clear the space and prepare the space. You're just not allowed to place any blocks of your actual building. All right, Melon Pan, what do we get? You got alternative splicing and Barbie. Nice. What have we got over here, Tompkin? We got planets, and you've got RNA polymerase binding. Nice. Aviation, what do we get? You've got show recessive inheritance, and you've got a Bunnings snag. Brilliant. All right, what do we got over here? You've got proximal and distal signaling, and you're incorporating a Labubu into that. Amazing. All right, Xenia, what we got? You've got Pokemon and temporal signaling. Nice. All right. Lettuce, what have we got? mRNA stability and an axolotl. Amazing. And EJ, what do we got? Cake and the tartar box. Brilliant. All right. Oh, and how could I forget? I couldn't forget Meowstick. How could I do that? Bowser and central dogma of biology. Amazing. All right. So, incredible. I'm just going to pull up a timer and so, okay. But feel free, if you want to put blocks in your hotbar, clear space out, you're more than welcome to. All right, so I'll give you 15 minutes. Ready? Time starts in 3, 2, 1, go. That's all right, Haley. If your thing isn't wanting to work, that's okay. Interesting. Oh, diamonds straight away. You love to see it, EJ. Amazing. Xenia doing a big think. We got Milo dropping the red dots, the red circles. The Labubu with the proximal and distal signaling. Oh man. Aviation going right to the fences with a Bunnings snag and the recessive inheritance. Oh, is it? Oh, look, Meowsy going for the flower? Interesting. Incredible. Do you guys have any favorites so far? For those of you watching, do we have any favorites yet? Go Milo. We got a Milo fan out here. Good luck, Milo. I believe in you, mate. Incredible. Yay, Milo. Oh, rip Xenia. Oh, she's back. Amazing. It's all right, guys. Just do your best. You're doing better than me. Milo is being very particular. You know what? Slow and steady wins the race. That's what I've always heard. I am too, Isabel. I'm keen to see the Bunnings snag one as well. I wonder what's left over. There should be one left. We've got Housekeeper Jean and Tacos left over as the last one that didn't get filled. Oh. Oh, nice. like a statue for Barbie and all mRNA stability. Is this a Barbie statue? I'm down here. Is this? Yes, a Barbie statue. Nice, nice. Oh no. All right, what do we got? What do we got? Labubu. Do you know what a Labubu is? Do you know what Milo? Do you know what a Labubu is? Is that what you get? Do you not understand Labubus? Or is it the proximal and distal signaling? With Google, yes. You're a good man. You can tell you haven't spent much time on the internet if you don't know what a Labubu is. Oh wow. Aviation going right in with the armor stands. Very cool. Hey man, you gain a little bit of respect in my eyes. It's all right. This could be your Labubu. This guy right here. You still got more than 10 minutes. You got plenty of time. 10 minutes is a long time. Oh wow. I see it. I see it. Wow, Xenio, nice. Look at that. Nice pixel art going on. Temporal signaling and Pokemon. Ah, Pikachu. Very cool. Wow. Look at this. Excellent. Oh, great. Look at this. Oh, it's Bowser's machine, Meowstick. This is cool. What are we doing over here, EJ? What do we got? Yeah, fair enough, fair enough. You're busy. I get it. Fair enough. Oh, there are axolotls over here, slowly wandering over to the water. Cake. Nice. Gonna make it? Nice. Good work. With tartar colors, I like it. Got him. Very cool. Oh, here we go. Milo's cooking with gas now. Here we go. It's that Labubu phase here. Oh, wow. You're cooking with gas over here, Aviation. Look at this. Oh, man. Tompkins. Wow. Going heavy with the wool, I see. What are we use again? Planets and RNA polymerase binding. I see. Oh, it's got Earth there. Nice. I'm not sure if that's RNA polymerase or something, but that's interesting. All right, we're at 9 minutes, everybody. 9 minutes, just so you know, just to keep your heads up. Wow. I'm quite impressed so far, team. Everybody's doing quite well so far. Yes, that's what happens when you've got randomization. You get weird things, but I have faith in your abilities to pull it together, everybody. I have faith in your abilities. All right. Very cool. Oh, you got the blue axolotl? Oh, it's escaping. How did it escape? Oh, did it get up on this? It must have. You might have to get rid of that part there. These little fence bits here. If you want it. Haley, the Mario thing, I think this is Bowser. Like, if you remember some of the older Mario games, Bowser used to fly around in something that looks like this. So I think what Meowstick is going for here is this is a the Bowser's little helicopter. And you're mixing, what are you mixing Bowser with? Bowser and Central Dogma of Biology. Interesting. Oh, the grill with the coral fan, I think. Oh no, that's a snag with the mustard and the ketchup. Very cool. Oh man. The fact that you know how to get, how do you, Steve head? Oh, they're all in there. There you go. Very cool. Oh, thank you. Beautiful. Oh, Bowser Jr. Thank you, Liam. We're just over halfway, team. We are at just under 7 minutes. The axolotls. They seem to be escaping unstoppably. Incredible. The great axolotl migration. Incredible. Look at them go. They really want to get to that water, don't they? Great work, Xenia. I love it so far. Pokemon and temporal signaling. How do you represent time with Pokemon? Dialga? Maybe. Axolotls in a TATA box. Glow and behold. Interesting. RNA alternatives. Oh, so Barbie's arranging the splices? Very cool. Very cool. Uh-oh. There we go. Lettuce, your axolotls are just wandering all around. I'll get them. Don't worry, I'll get them. I'll get them. All right, Milo, how we doing? How we doing, man? Oh, that's a great Labubu face. Well done, sir. Well done. Cells yippee. Oh man. Under 5 minutes. Yes, cell migration as well. The axolotls also represent cell migration. That's a great point, Liam. We had cake and tartar box. Ah, TA. Oh, I see cake made out of the same blocks that were used for TATA. I see it. EJ, don't even worry about it. Don't even worry about it. You're doing just fine. Very good, Meowstick. Very under 4 minutes, guys. Yes, I will. I'll be doing 2 more tutorials after this, Raphael. So I've got this one this week, next week, and the week after, and then that'll be it for my little stint. But you've got me, whether you like it or not, for this week, next week, and the week after. Also, remind me to let you know. Yes, remind me to let you know. I do have a little bit of a little preview of what we might be doing next week. So remind me to. No, it's not going to be Minecraft every week unless there's like an uproarious, unless everybody's like, please, please let it be Minecraft. But I do have something planned for next week, and I do have like a little outro slide to do at the end of this. So hopefully I don't forget. So if I do get to the end of this, and please just remind me about that, but so I don't end off here without they know how mRNA stability works. If you put them all in a small enough water, they're stable. I love it. Nice. Oh, yeah. Oh, I see it, Tompkin. I see the vision. I see the vision. All right, we're at 2 minutes 30. 2 minutes 30, guys. League of Legends, are you Valorant? That would be funny, wouldn't it, guys, if we did this in League of Legends? COD? Nice. You any good at COD, EJ? I'm not any good at COD. I used to suck at first-person shooters. I don't know why. I never got that good. I was never any good. Roblox? I don't know. I mean, that's a bit risky. I don't know who would want to go on Roblox. But that could be TF2? EJ? Oh yeah. Oh yeah. I see it. I see the vision. Sorry for all those Roblox enjoys. Oh, Red Dead Redemption 2? That would also be great. I was a humongous fan of Skyrim. Humongous fan of Skyrim growing up. Wow, Barbie rearranging. Very good. Okay. You've got 1 minute and 10 seconds left, everybody. 1 minute, 10 seconds. GTA 5? When GTA 6, though? When's that coming out? You know what I mean? Hasn't that one been coming out for years at all? Disney Dreamlight Valley. Oh, I haven't heard of that one, Caitlin. Is that one fun? What is that one about? Is that, oh, you know, Tompkin, you're really pulling it together. Deltura. Oh, yeah. Oh, Deltarune. Okay. Cozy game. Gary's mod. Oh, man. Minecraft lecture before GTA 6 is crazy. Gary's mods. This is getting oddly specific, guys. All right, everybody. You got 15 seconds. 15 seconds. All right. 5, 4, 3, 2, 1, and time. Great work, everybody. Great work. I'm loving what I'm seeing here. It's doing really well. I'm very impressed. You guys have done better than me. As I said, that's my build over there, and it's just like blobs. Oh, how much did you go over the line? What do you think, Melon Pan? Is that what do you think? He's encroaching on your space? Do you think we care about that? What do you think, Melon Pan? Do you think we care? Yeah, it passes. Yeah, that's what I thought too. That's all right, Xenia. You're all good. All right, so I forgot to set up a scoreboard, so we'll just do one over here. Alrighty. So, life or death, wow. So, how many people we got? 1, 2, 3, 4, 5, 6, 7, 8. Yeah, right. Okay, well done, everybody. I'm very impressed. Everybody did very good here. You did as good if like you can see my building style across the way. You've been looking at it all this time. So you know what my level of building is, and I think you've all met that or exceeded that at least. All right. So can everybody please put your name on the top row here in one of these signs for me? And we'll have accuracy. We'll have creativity. And we'll have people's choice. And it'll be out of 10 for everything. All right. So Oh man, I should have set this up before. I'm sorry, everybody. Yeah, thank you. Can we fill this in, please? Can you? Thank you. I appreciate it. I'm sorry, I should have set that up earlier. But we're here now. We're here now. So we'll go left. Oh, nice one, Tom. We'll go left to right. And we'll start with EJ. So, EJ, you've got cake. You've got the TA, so you got the TATA box. So, in terms of creativity, I'll give you 5. I think it's about I will admit you had a bit of a hard one. It's a bit rough out here having to do a cake with the TATA box, but you did include the different colors from what we did over there. So that's a nice callback. It makes me feel good because it strokes my ego a little bit. So I'll give you a 5 for creativity. For accuracy, I'm not really sure. I'll also give you a 5 as well, because you also included the TATA combination here in a cake. So it is a TATA box is just TATA over and over again. So you went TATA. So I'll give you a 5 for that as well. So now we're going to go to the people. And we're going to go to the people. We're going to create a poll. How do I? And we'll see if we can't create a poll for the people. Do you have to do it outside of the meeting? Anyway, there'll be another way to do it. All right, everybody. On a scale, I want everybody in the chat, I want you to put a number between 1 and 10. Don't send it off just yet, but when I say go, I want you all to press enter and send out your 1 to 10 score, and then I'll just take an average of that. So ready, everybody get your score ready for EJ. And in 3, 2, 1, go. 6, 7, 6, 7, 6, 7, 7, 6, 7, 7, 7, 3, 5. All right, so I get a whole bunch. We got 7. All right. I'm going to say that averaged out to be about 7. So, EJ, great work. 5, 5, and 7. Beautiful. To give a total in there, 5, 5, 7 of 17. Great work. No, that's all right, EJ. You did better than I could. All right. Next up, Lettuce. You were over here, weren't you? No, that's the... Where were you, Lettuce? This was yours? Beautiful. So we've got mRNA stability and axolotl. Axolotl's definitely big in here. You've got axolotls sitting up here on the mRNA. Also, it's stable. Because it's evenly balanced. Ah, yeah, and you've got the individual components here and mixed together. So I can see, I'll give you about a 6 or a 7. I'll give you a 6.5 for accuracy. And for creativity, it is sort of axolotls being there. I'll give you a 5 as well. So far, we've got a 6.5. We've got a 7. Oh, we've got a 5 for creativity. And all right, same deal, everybody in the chat here. Get your number ready. And then when you're ready, just hold on for a sec. And in 3, 2, 1, go. All right. 8, 7, 6. I'm going to say that's also a 6 as well for that one. So well done, Lettuce. Good on you for coming out and doing great work there. So that one comes out to be 17.5. Well done. Next one along is Xenia.
Hi, Hayden.
Yes,
It's Dan
Diane.
here.
Yes.
I think I've made a poll if you want to try it for the next one.
Oh, perfect. Thank you, Dan. I appreciate that.
I will launch it when you tell me to.
Amazing. That's perfect. All right.
I hope it
So
works.
we'll figure it out if it works or not. Thank you, Dan. That's great. All right. So we had Pokemon and temporal signaling. That's okay. So Pokemon, I see it. We got 2 Pikachus, and then we've got eats a bug, and then sweats. Okay. Temporal signaling. I think I might have to give you a 4 for accuracy, just because I'm not sure how much temporal signaling is going on with specific genes in here. But I like the creativity. I like the but the creativity, I'll give you a 6 for that one. So we've got a 6 and a 4. And Dan, could you try the poll
Yep.
for me, please?
Okay, let's see. Is that showing?
Yes, it is. It is showing for me.
It does go up to 10, yeah.
Perfect. All right.
Can you see the results, or do I need
Yes,
to?
I can see the results.
So it
Don't
looks like
worry.
6 is the highest at the
6
moment.
is the highest. So we'll go for 6 then. We'll end the poll there and we'll go back. So the highest score being 6. So that gives you a total score of 16. Well done. So we'll just plop down 16 down here just to keep it simple. All right. So after that, we've got Daisy. So where are you at, Daisy? Where are you? You are over Middle Bowser. Wow. Very cool. Very cool indeed. So in terms of accuracy, I can see here you've got your protein, nice. You've got your DNA, nice. I would have liked to have seen maybe an mRNA strand in the center. Hold up though. RNAs, very impressive. Daisy, I'm very impressed with that. Well done. That's got to be like an 8.5 for creativity. I was about to get rid of some points because you missed RNA, but I'm very impressed with that. So accuracy, I'll give you a 7. Creativity, actually yes, because I would have liked, you're missing a couple of the enzymes to go from one to the other. So that's why I'll give you a 7.5 because you've got most of it in there. And I'll also give you a 7.5 for creativity. So very impressive. Dan, could you give
Yep.
me the poll again, if that's going to work?
Okay, there we
Amazing.
go.
Yes. And so if you could give me a score for Daisy, please. One person immediately gives a 0. Okay. Somebody's a little salty, maybe. Or
Ooh,
maybe that was a
scoring high.
mistake. Scoring high, that's for sure. All right. I think we'll give everybody a couple more seconds. Excellent. So we're going to end the poll there, and about a third of people voted to get the 10. So that's what we'll do there. So that would give you 25 points total. Well done, Daisy. Very good stuff. Amazing. Well done. And we'll move right along. Who is next? Milo, Labubu's, and something else. Labubu's and proximal distal. I see. So I love the face. The face is great. Proximal, cells yippee, and you've got a Labubu being close. That is incorporating it together. And you got distal, and then you've got the yellow because electricity. I don't know. Excellent. So to give you accuracy, I'll give you a high score for accuracy because you are accurately representing the distances. So I'll give you 7 points for that. And because of the face, I like the faces a lot. So I'll give you maybe I'll give you a 4.5 for the face as well. But yeah, good work on something. I think you did so far. You and EJ definitely had a hard situation to put together. So well done, Milo, on getting something together. This is so bad. No, it's not. It's not that bad. All right.
I'll
Dan,
do the poll, yeah?
yes, please. All right, everybody, what are we thinking? All right, I think that is gonna do it. And just edging out is 5. So well done. I think that gives you a total of 15.5 if my math is correct. Well done. All right. Who is next? Aviation. Where are you, aviation? You're over here at the sausage snag, right? Very cool. I like how you've got the setup here. Very sausage, very snag. We've got child, father, mother, and you've got down here, you got the sausage as well. So the individual Bunnings snag and the show recessive inheritance. So the individual components are there. I would say you probably could have incorporated them together a little bit. So maybe, for instance, if you had 2 hot dogs as like the mother and father, and then the child being a mix of the hot dogs. So, but you've got the individual components quite well. So I'll give you about a 7 for displaying accuracy. Actually, yeah, 7.5. I'll up it a little bit. And I might give you a 5 for creativity because they look very good individually, but I'm not sure if they're super incorporated. But they look great individually. I'll give you that. All right. Dan, would you please give me the code? So 7.5, so we're at 12.
There we go.
We're at 12.5. Nice use of coral, I agree. All right. That
looks like a 7.
Looks like a 7 to me. So that would be 12.5 plus 7, 19.5. 19.5. Well done. Aviation. Very good. Very good. Beautiful. All right. Tompkin. All right, where are we? Where are we at, Tompkin? We're at Barbie, right? Or are you planets? Oh, you're over here. Very nice, Tompkin. I didn't know where you're going to start off with, but I see the vision here. From Earth, you've got the sequence. Talk me through, what is this, Tompkin? Is this a planet or what is this? Take your time. You're right. No rush.
This is actually the RNA polymerase.
Yes, I thought so. And then afterwards it goes out into this direction. Very cool. I like the incorporation. I think I'll give you a pretty high score for incorporation. And accuracy isn't too bad either, right? Because it's planets and it's got in the chain there, and you got like the solar system. You got Saturn's ring. You've got Neptune. Very cool. So I'm going to give you 2 7s. 7 for creativity and 7 for accuracy. Dan, could I please have the poll? There it is. Looking like it's pulling ahead. Beautiful. I'll end the poll there. All right, so 7 points for you, Tompkin. Very good. 21 overall. Great score. Well done. Beautiful. So, Melon. Last but not least, Barbie and alternate splicing. The alternate And look at that. You even included the poly A tail for the mature. So I think for the accuracy with Barbie like holding it and rearranging it, I'm gonna give you a 7 as well because I like how accurate it is. And the creativity of having Barbie doing it as well, I think that's worth at least like a 6.5. So I'm gonna give you a 6.5 and then a 7 for accuracy. No, I think it's 7 and 7 again. I think I like the accuracy and I like the creativity of it. So Dan, could I please have the last poll?
Here we go.
Oh, gonna give it another 5 or so seconds for people to get them in. Oh, it's an even split between 8
8 and 10.
8 and 10. So I'll split the difference and I'll go 9. And I'll go 9 with it. So 779 gives us 23 points. So overall, 23 points. Great work, all of you. You've all gone to at least my level or above, as you can see over there. But ultimately, only one can stand above. And well done, Daisy, with your great Bowser-inspired Central Dogma. Well done, Daisy. And that's it. We got there, team. Thank you for coming along with me along this journey. Before that's right, I better not forget. Is this coming up? Is the PowerPoint coming up?
Yes.
Excellent. So next week, for those of you who are going to be here, next week, you might know the game, you might not know the game, but your parents definitely do. We're doing Jeopardy. We're doing Jeopardy. We're going to be answering some questions. I'm going to be your game host, and we're going to see who knows the most. All right. But yes, that's it. If you do have any feedback for me, please let me know. It can be good, it can be bad. You could just be indifferent. Please feel free to email me. That's my staff email address there. So feel free to send me an email. As good as you like it to be, as bad as you like it to be. I like some positive reinforcement, but I also do take on all criticism. You can be as mean as you like. It won't affect me, I promise. If you don't like to do that, if you'd like it to still be anonymous, feel free to do the anonymous student survey at the end of semester if you'd still like to be anonymous and give it there. But yes, thank you all for attending. All the official work is finished up here, but feel free to hang around and chat if you'd like, or send me some messages. But apart from that, we're done for the day. So thank you for joining me.
Great. Thanks, Hayden. I'm going to stop recording now, so I'll do that.
Thank you, Dan. I appreciate you.